So far, we've been working on counting in our reactions, right? We just counted a lot while we were balancing. But we also want to be able to measure when we have reactions, right? Because that's what's easier to do in lab. You put something on a balance and you weigh it. You don't count up atoms of sodium, right? This is like models, but we don't count those when we're actually doling out, say, medicine for a patient. So in chemistry, we have to translate between counting and measuring. When we count, we can count very small particles like atoms. We can also count larger groups of atoms called moles. And then we can measure, for example, grams. How much do these actually weigh in a lab? And so what we're going to see on this slide is how to translate between these particles, these groups of particles called moles, and then grams. All right, and this is going to be our main focus because in your practical vocation of nursing and health, you're more likely to weigh something than you ever are to use these other two units. All right, so in terms of counting, we've already kind of been doing this. Counting atoms, and then moles is our new quantity, which is defined over here. And we've been counting using these coefficients, right? There's a 1 here, there's a 2 here. We actually count using these subscripts too, but the coefficients we've been coloring in green. So I'm going to say that we have 3 ways to count and measure. So the first way that we can count is we can count atoms, and that's really what we've been doing when we've been balancing equations. So when we count atoms, we would say I have 2 atoms of sodium, I have 1 molecule, I could say, of Cl2, and then I could say here I have 2, we don't call it a molecule because it's ionic, but we could say we have 2 formula units of NaCl. And notice those numbers, counting, all match my coefficients, right? Now, a mole is just a group of atoms, and you're kind of familiar with this. Eggs, we don't really count like individual eggs. Hey, John, could you go to the store and buy me 1 egg? We say, can you buy me a dozen eggs? So same with atoms, we don't usually talk about individual atoms, we talk about moles of atoms or large groups of atoms. So counting moles is another way that we can quantify what's going on in a reaction. So this would be 2 moles of sodium react with 1 mole of Cl2 to give us 2 moles of NaCl. And again, this is a scaled up kind of bigger group like a dozen would be. And again, notice the numbers stay the same. So 2, 1, and 2. So counting atoms, counting moles. Just a note also on mole. Mole is a funny word, not like the mole that lives under the ground, but the abbreviation for it in chemistry is MOL. So sometimes you'll see me write mole with an E and sometimes not, and that's just, I don't know, the world's most useless abbreviation. A final thing that we can do is we can actually measure grams. So instead of counting, we say, no, I just need to put this on a balance, or you might use a syringe if you're looking at volumes, but I need to actually measure this. If I weighed out these 2 moles of sodium, I would find that I had 45.98 grams of sodium. And if I weighed out a mole of chlorine, I would find that I had 70.90 grams of chlorine. And notice I'm putting the chemical on here because I want to specify what it is I'm weighing out. So that's a part of your units. And if I weighed out my products, my 2 moles of sodium chloride, I would have 116.88 grams of sodium chloride. All right. So these are nice, simple to count. These are easier to measure. Now, if I want to go between those, okay, if I want to translate or convert, so remember conversions are kind of like translations, and you need a unit conversion or a translator to get between them. If I want to get between these, I have some different conversions that I can use. So here are 3 different conversions, and we're actually only going to have to use 2 of them when we look at our chemicals in reactions. The first conversion that we have is called Avogadro's number. If you've taken chemistry before, maybe you've heard of this. If not, don't worry about it. This is a constant that scientists were able to determine. So instead of doing eggs per dozen, with Avogadro's number, what we do is we do atoms per mole, or just small particles really. 6.022 times 10 to the 23rd atoms or other small particles per 1 mole. That's Avogadro's number. And just so you know, brackets here, we won't use this. Because I have never gone to my cabinet and said, I want to take 2.1 times 10 to the 22nd atoms of carbon in my ibuprofen today, or I need to eat so many atoms of hydrogen today. We don't really care in our daily life about atoms. They're too small. The scale is just too small. So this is here, but we won't use it. The next conversion that we're going to be able to use is called molar mass. And you can hear in there that there's something about moles going on. And this is going to be a way to get between moles and grams. See the mass there? So molar mass, you are going to want your periodic tables. So find those if you don't have them handy. And these molar masses are always going to have the units of grams per mole. So grams per mole. So for example, if I'm looking at sodium and I go to the periodic table, you just want to know how to use your periodic table, right? Don't memorize it, just use it. This mass here at the bottom, 22.99, tells me in grams the mass of 1 mole of sodium atoms. So I could say 22.99 grams of sodium, again, put the chemical on it, per 1 mole of sodium. All right. Couple things about this. So this is called molar mass. We found it on the periodic table. It's those bottom numbers. And the units are always going to be grams per mole. You might see that written grams over mole, or you might see grams per mole, but those mean the same thing as each other. So molar mass lets us go between grams and moles. And then a final conversion that we're going to use is called a mole ratio. And this is where we have reactions happening. And we want to say, okay, well, if I have this much sodium, how much product can I get? Or if I need this much product, how much reactant should I use? So when I look at mole ratios are always going to be moles of one thing. So counting one thing and then counting something else. And so if I was to look up here, these coefficients are going to give me my mole ratios, or kind of the recipe for how things are related together. So I could say that for every 2 moles of sodium, I'm able to make 2 moles of sodium chloride. Coefficient, coefficient. And let me just color those in so you can see them in my mole ratio. Another relationship here, I could say, okay, well, what if I have instead 1 mole of Cl2, then I could also build 2 moles of NaCl. Again, I grabbed the coefficients. And there's a third relationship here. I could say, okay, if I have 2 moles of sodium, then that will react with 1 mole of Cl2. So those are the 3 possible mole ratios. And remember back when we did conversions back in chapter 1, you can go review those if you need to. Any of these conversions, we can flip upside down, right? Because this is actually equal to 1, so I can put moles on top and grams on the bottom if I need to. And so over here, just to leave ourselves a little note, we are always going to look at the coefficients when we are working on these. All right, one more little connection or analogy for you. If I'm thinking here about Avogadro's number being small items scaling up to a big package, that would be like saying I have however many eggs per dozen, okay? And then if I look at an analogy here for molar mass, that would be like saying, well, what if I don't want to count eggs? What if I just want to throw them on a scale and go from there? Then maybe say every egg weighs 100 grams, which I think is a low estimate. Then I could maybe instead say, well, let's take those dozens where we counted and turn it into a mass, so I can just weigh it. All right, so now I could just weigh out 1,200 grams of eggs and I'd know that I had a dozen. Finally, what if I want to use those eggs, okay? Eggs in my fridge are boring. I want to make cakes out of them, okay? Or I want to make whatever you want to make out of eggs. So I don't have a reaction written here, but I know it takes 3 eggs for every cake. And so I also know that if I have a dozen eggs, which is 12, I can make 4 cakes, all right? And so now I'm counting. This is more like a recipe here, where I'm saying, okay, if I have a dozen eggs, I can build 4 cakes. If I have 2 sodiums, I can build 2 sodium chlorides. So we're looking at particles to a larger group, or a group to a mass, or a group to let's make something out of it. So that's a little analogy that might help you kind of put all these pieces together. So next page, we will use molar mass, and then after that, we'll do some mole ratio examples.